Dear participants, you may please switch off your video. Thank you.
Good evening, ma'am.
So today we reach to the sixth day of our online workshop, and just one day left over for this entire session to reach its culmination. I welcome all the dear participants today to hear a special session, a special deliberation with our speaker on regression. And as we all know that this is something that we all need to understand about the sampling methods and the regression techniques, beta and stepwise, this is what a special session is all about today. Well, today in the morning, I came to know about Professor Amya Kumar Bakshi. And yes, we all know that he was a renowned economist, a scholar, and a public intellectual who passed away last evening. We all know that he was a dedicated advocate of left politics as well. And hailing from West Bengal, he did his master's from Presidency College and his doctoral studies at the Cambridge University, where he also joined as the Faculty of Economics and Politics. Bakshi served as a member and vice chairman of the West Bengal State Planning Board during the Left Front government's tenure. And after this government service, he founded and led the Institute of Development Studies, Kolkata. I would also like to share about his groundbreaking work, Perilous Passage, Mankind and the Global Ascendancy of Capital, which explored the far-reaching consequences of imperialism, particularly the demographic collapse in the global south. A profound thinker, Bakshi maintained strong connections with eminent Cambridge economists like Maurice Dobb, Piero Sraffa, Richard Goodwin, and Joan Robinson, and his unwavering belief in a future free from exploitation will continue to inspire the generations to come. Let's give a tribute to this institution builder with today's lecture by our speaker, Dr. Sourav Kumar Das. We welcome you, sir. And before I hand over this platform to you, I would be privileged to read about you, to read your profile to our participants. Dr. Sourav Kumar Das is a senior faculty of economics at Women's College, Calcutta, under Calcutta University, with an expertise in several important areas of economics. His specialities include tribal economics, where he focuses on the economic issues affecting tribal communities, particularly in rural and remote areas. Additionally, his research interests cover poverty and how economic policies and practices can address socioeconomic disparities. He is also involved in forestry and its economic implications, likely analyzing the role of forest in sustaining local economies and ecosystems. Dr. Das has made significant contributions to his field through numerous publications in both reputed international and national journals, as well as in books also. These publications not only showcase his academic rigor, but also highlight his ability to apply theoretical knowledge to real-world problems. His work is valuable in advancing the understanding of these complex issues and informing policies aimed at improving the lives of marginalized communities and promoting sustainable development. We welcome you, Dr. Sourav Kumar Das, and we request you to please begin with your lecture on the topic that you have selected, sampling methods and regression techniques, beta and stepwise. Thank you, sir.
Thank you, ma'am. Last night I have got the news regarding Bakshi sir. So actually, I am not his direct student by heart, but heard lots of lecture and read lots of book of him, and which gives us that knowledge and that particularly that information and that essence of research for so that we can come here to do something in our research world. So for today, this is actually a very sad day for us. From morning, we got lots and lots of messages in social media as well as in our group, that we have a group on that all of us who in economics who are studying and doing economical different types of jobs and like that. In that group, lots and lots of message, lots and lots of stories are coming. So actually, that makes us uh, too much nostalgic that we lost a very we lost a person, we lost a huge tree, so that there from him we learned lots of things.
I think, sir,
So
perhaps for this, let's give this lecture a tribute to Amir Kumar Bakshi through
yes,
this
yes,
lecture, of course.
definitely, definitely, ma'am. And thanks, Department of Economics, Dr. Shakuntala Mishra, National Rehabilitation University, Lucknow, to give me that opportunity to share my knowledge regarding sampling techniques and give you some knowledge regarding some special type of regression. Uh, Actually, since last 14 years, I am doing on-field surveys, collect different types of data in different remote areas. So that gives me some field knowledge uh, that how sampling can be done for fulfilling our objective. This is the main thing. And after collecting the data, uh, because there has been lots of problem regarding us when we want to do a modeling in econometrics, that what will be the appropriate methodology, what will be the appropriate model for fulfilling our objective. So today I will tell you two special model which can be used in our research a lot. And why I am telling that these two, particularly one model, which will be too much useful for early births who are in research, because that will help you a lot for selecting the variables for doing research and for doing modeling. So I am starting my lecture. So thank you and be a lot for giving me this opportunity. Uh, just one thing. Yes, is it visible? The slideshow is visible to all now?
Yes,
It's
sir, it is.
visible.
Yes.
Yes, yes, yes. So let's start. Mainly, what we will learn today, that first of all thing is why sample is necessary for research, because sampling is a main thing for our academic research, particularly in social science. Because since we are studying social science, there has been lots and lots of scope of research, and sampling is the only way for fulfilling our data for researching. And after that, what is the relationship between population and sample? Not like that actually. How sample can be drawn from population, and during the time of collection, what will be the problems regarding sample collection, and after, what are the different techniques through which we can collect sample. And there has been two techniques mainly, probability sampling and non-probability sampling, that we will discuss later in this session. And after collecting the sample, the main thing is that the modeling, that means the representation of data, that our objective, how we fulfill our objective through different models. In the previous lecture, you will learn about different type of regression techniques, and today we will know about two special type of regression, stepwise regression and beta regression. So, what is a sample? Actually, those who are not in social science also, we are aware that what is sample. When we go to the shopping mall, or when we get to some uh, cinemas or in multiplex, there has been some people with a little bit of form. They are collecting some data. They are asking that what are the, give some ratings and like that. So they are collecting the sample from us. This is sample. This is all of we are knowing about it. So what is a sample? Sample is a subset of population. Means sample is nothing but a part of a population through which we can know, we can analyze, we can estimate the population. We can estimate the population. Actually, the main thing is that when our mother is cooking that rice in a big bowl, what she will do, she will just take rice, and from that rice she can analyze that that whole bowl has been prepared or not. So that particular rice is the sample. So in our daily life, we have also that live in a big bowl, rice bowl. There are lots and lots of population and lots of study area um, around us. So when we want to study particularly on that area, we will face a problem that there has been lots of population, and we do not have such amount of money and such amount of time to study that particular population. For this reason, we need sample. Uh, and another most important thing is that sample is also necessary for reducing bias also, because and increasing feasibility also. So for us, for the students of social science, the researchers, sample is a good instrument for studying population. uh, is it clear to everyone? Am I
Yes, sir.
audible?
Yes, sir.
Yes, sir. Okay.
Yes, sir.
Now the next thing is that why we need sample. Suppose you want to study that the pass out students of a university are placed where, what are the placement that they got after passing out from university. So there has been lots and lots of students who get different type of jobs in formal sector, in informal sector, uh, in India, in outside India. So it is not possible for us to collect each and every data, and we do not want to go each and every students and collect and ask them what are you doing, what are your salaries, how do you go get your job. So there has been a lot of time taking process, and this is also too much laborious. We cannot complete our research work like that. Since our universe is too large, since our data elements are too large, that's why for any research or anything, any study, we have to collect sample only. Another most important thing is that in India, what we know that total population has been collected 10 years lagging. That means in 1991, census, in 1991 we got census, we got our census. That means the study, the data of entire population. In 2001 we got the same. In 2011 we got the same. Due to COVID we not get yet on for 2021. So think about our economy. If we want to study total population, so government take 10 years to collect and publish a data. So for our research, how do we take population data? So for us, sample is the one-way track for research. And another thing is that you cannot interact to the person, to the communities that you want to study. That can only be possible if you study sample. And for a big um, researcher, for a big data, if you want big data for your, suppose for if you are doing your PhD, so you need some valuable data regarding your thesis. So you need at least some significant data. For that you have to go each and every person to collect data regarding him or her. So that is the need of sampling. So without sample, we cannot conduct any research or any your thesis or any report. We cannot do anything without sample. And finally, sample is nothing but the reflection of population. We will study sample for studying population. Suppose in our northeast India, there has been lots and lots of tribal peoples living there. So if we want to study the livelihood of those tribal people, so it is not possible for us to go to Assam, go to Tripura, and go to Nagaland, go to Manipur, and go to Arunachal Pradesh for and go to Sikkim also to collect each and every data of tribes, go to their houses and collect data from us. What we will do? We will make a list, make a frame that these are the tribes, they are living in those areas, and take sample from each tribes. Suppose a tribe called Santal. We can take data of Santal. We can take little bit of data of Bhutia. We can take little bit of data of Mundas like that. And after that, we will reflect those data like that, that these are the reflections of population. So this is the importance of sample. Now, what is population? Population is nothing but our whole economy, our people, our livelihood, events, the time frame, all things comes under population. If you want to study, suppose if you want to study the transition of those tribal people, that due to our reforms, due to our uh, increment in livelihood, tribes are forced to change their livelihood pattern. They are forced to change their consumption pattern. They are now not at all dependent on forest totally. They are trying to be become marketed. So how the tribes are changing over time, the total time frame will comes under population. And what is sample? Sample is the subset of that population. Suppose Santal tribes. The transition of Santal tribes will start if we want to study the total population. It can be start from that British era. But for an individual researcher, we cannot study, we cannot gather data from British era. What will we have to do? We can collect data after 2 years gap or after 3 years gap. Suppose we have some data in 2015. After that, we have collect some data on 2020, and after that, we collect some data on 2024. So these are the time data or time series data about tribal people, and that we have collected through sample technique, which will we give the reflection of population. So there has been some logical significant relationship between population and sample. And sample is nothing but a part of population through which we can analyze, we can gather, we can study the population. And population, the characteristics of sample must be equal or must be likely to population also. You can see I have give a little bit of picture here, that there has been a lots of people living in a city, and that is our population. And we want to study that what are their monthly income. Suppose we want to study, this is a picture of a city. Suppose we want to study the income of that particular small city. So what will we do? If we want to total population, we have to collect, we have to go each and every individuals, take data of each and every individuals, and we can make some mathematical interpretations. Their income, take some average, mean, we will calculate mean, and after that we can tell that monthly income of this city is like that. This is the population survey. Now, since this is a too much time consuming and also need lots and lots of money also, so we will take random sample. We will take individual 5% individual or 10%. Suppose a population is 1000 in a city. So we will take 10% of data from that. That means we will collect 100 data of individuals, and from that we will analyze their monthly income and we will get the sample mean of that city, which will be equivalent to population also. And if there has been some difference, that we will discuss later. So how we collect sample, that is the most important thing of today's study. Last 20 minutes we will study about what is population and what is the relationship between sample and population, and the breach, the gap between population and sample would be completed through sample technique. Sampling is nothing but the technique through which sample can be collected from population. So sampling can be collected through our beautiful technique from population, so that we can get proper sample, so that we can estimate proper characteristics of population. Okay. Now, when we will study population, there has been some terms that we have to know. The terms, what are the terms? The initial terms are, what is population parameter? Parameters are that we have discussed for last few minutes. What are the parameters? The income of individuals, the livelihoods, the averages, their occupations, their education level. These are the population parameters. And next is population element. Population element means what are the element in population parameters? What are the age groups? What are the different type of education levels? These are the population elements, and through which we can break the total populations into some population stratus, population stratum. Suppose we want to study in total population, there has been men, women. So suppose we divide our total population in men and women. Suppose we divide our population in general, scheduled caste, scheduled tribe, and OBCs. Suppose we can divide our population in different castes also. This is called population stratum. The similar concept is also for sample. Sample frame is nothing but the from population we want to study. From population, we will take sample, and that sample is nothing but the sample frame, the policy through which sample can be drawn, and what are the sample units that we have to know. And after that, when we want to collect sample, we will face lots and lots of biasness. This is called sample bias. So what is sampling bias? Sampling bias is nothing but when you have collect some data, and after that you will, after analyzing it, you have noticed that the result of sampling is not tending towards population. So there has been a sampling error during collection. So during the process of sampling, we have to know our objective properly, so that after that we can collect data from the directly field of inquiry. There has been some other bias also that are called non-sampling bias. Non-sampling bias are like that you have thought that from these questions, from this questionnaire we will gather these type of data, but after getting that data you will analyze that the data are not giving that appropriate results you want. uh, so, and another problem is that suppose you go to a house for some data, collecting data, and they are giving the opposite scenario that that population are giving. So if this type of error will occur, these are called non-sampling bias. Basically, sampling bias is the error due to faulty sampling process, and non-sampling bias are the error due to non-responsiveness or false responsiveness of individuals. So these two types of error can be drawn. So basically, sampling bias can be controlled, but non-sampling bias cannot be controlled because non-sampling bias is dependent on the individuals who are giving their information to the researchers. Now, how we will gather data from population through sampling process? I have given a flowchart here. First, suppose take an example. Suppose we want to study a particular tribal group. Suppose Rai of hill tribes. Rai is one of the most important tribal community of hilly regions of India. Suppose we want to study the livelihood of tribal communities of a Rai communities. So first we have to target our population where we have to study. This is our first thing. Second, selecting sample frame. Selecting sampling frame means we have to determine that Rai tribal communities are belonging from which state. These are the frame of my sampling. After that, we have to specify sampling units. That means in which state we have to go, and from that state, how much, what percentage will be the sample that we have to collect of Rai community. After that, we have to select the proper sampling method through which our objective can be fulfilled. This is the most important part of sampling process. Suppose you have misinterpreted the sampling frame. Suppose you have falsely, there has been some error on sampling unit that has been rectified later. But your sampling method must be appropriate during your sampling. And finally, after sampling, after choosing that sampling method, we will determine our sample size. Sample size also determined after analyzing the parameters of population. The data are homogeneous or heterogeneous, the data, the situation of the data, the location of the data. After that, we can decide what will be the sample size of our sample. So this is our total sampling design process. Now, the most interesting and most important part of today's lecture is what are the different types of sampling method. Initially, we can divide sampling methods into two parts. Number one is probability sampling and another part is non-probability sampling. And there has been lots of sampling type that comes under probability sampling. Those are simple random sampling. You have some knowledge and you have read about simple random sampling because it is most famous and most easily accessible, easily doing sample technique. And another is double random sampling. The next one is systematic random sampling. Another is stratified random sampling. Another one is cluster random sampling and multi-stage random sampling. First of all, concentrate on probability sampling. Later, we will discuss about non-probability sampling. Now, what is probability sampling? Probability, as we know, is the probability is the opportunity of probable outcome. This is probability. So probability sampling means the population that we are studying, the individual living in that the tribal communities, the tribal individuals who are living, suppose the tribal individuals who are living in Tripura, the tribal individuals who are living in Tripura, suppose they have, when their probability is same, suppose there are 1,000 tribal population living in Tripura. That means when we want to study each individual have probability of coming is 1 by 1000. That means each tribal community have same probability for selection. This is called probability sampling. That means probability of outcome for selection is same for each and every member of the sample. This is called probability sampling. Suppose there has been 10 ball in a bowl. So what will be the probability of selection of a ball? The probability of selection of each ball is 1 by 10. And another thing must be noted here that probability sampling is the mostly accepted sampling when you will do quantitative as well as your qualitative research. Now, for probability sampling, the most easy and mostly used technique is random sampling, rather simple random sampling. Simple random sampling is used by everyone. Simple random sampling means randomly we will take, suppose we will take that 1000 tribal households who are living in Tripura. We all went to Tripura and we take some note that the tribal families, that 1000 tribal families live in those different areas, and we will go there without any determination, without any systematic technique. If we collect data randomly, suppose we take the second house, suppose we take 10th house, suppose we take 22nd number of house randomly according to our willingness, we will take data randomly from the field of inquiry. This is called simple random sampling. But the most important thing is that you don't have any preferences, you don't have any biasness, you don't have any judgment here. You cannot judge anything for simple random sampling. Suppose when we go to inquiry, some funny note is there. Suppose there has been a house, that house is beautifully decorated, and you have collected a data of that house, and after that there has been a house, that house is more decorated than previous one. You, that means you are preferred that this house is more beautiful. You cannot take data from that house, because that will be a preferable and that will be a non probability data, that will become a non probability data. Random sampling means you can take randomly. Suppose you take second house, then you can take fifth or sixth house, after that you can take 10th number house, after that you can take 22nd, 25th, 25. No logic behind that. You can take only data randomly, without any measurement, without any preference, and without any judgment. And another most important thing is that for simple random sampling, when the today I will tell you when you will use the simple random sampling. Simple random sampling is only used when your data is homogeneous. That means we will take an example that tribal family. That means we are studying only on tribal family. So our data is homogeneous. We cannot take data in hetero if the data is heterogeneous. Suppose we are studying in an area where there has been some general people, there has been some scheduled tribal people, there has been some scheduled caste, and there has been some other backward class people also. From there, we cannot collect data through simple random sampling. That means simple random sampling can be used only if your data is homogeneous. This is the first most important thing. When you are studying a data which is homogeneous, you can use simple random sampling. Now the second part is if your sample size is small. There has been lots of question regarding this. What is the number of small sample size and what will be the number of large sample size? Small sample size means when you can control your data set. This is small. Suppose that we take an example that there has been 1,000 tribal households are there, and you are going there to collect 10% of data. That means 100 household we have to collect data. So if we can take 5% of data, that means 50 household we have to collect. Since 50 household is quite less, that means our sample size is less, and since data are homogeneous, all the households are from tribal community, and they are living in a same state in rural areas in near to the forest. That means these data are homogeneous, and since our population is quite small, 1,000 only, that means we can data from here through simple random sampling process. Clear? Is it clear to everyone?
Yes, sir. Yes,
Yes,
sir.
sir.
It's clear.
Okay, okay. Now there has been two technique. Again, the simple random sampling has been classified into two techniques. First one is simple random sampling with replacement, and next one is a simple random sampling without replacement. I have given a little bit of picture here for your help. See the first diagram, that with replacement diagram, there has been six balls in a bowel, and that means the probability of collecting each ball from this bowel is 1/6, since this is a probability sampling. So with replacement means, suppose a ball has been collected from that bowel, that one ball, that is our sample, and after collection, what we will do, we just note the number of that ball, and the same ball will be again comes under that bowel. That means number of ball after selection, each ball will be same. That means after collecting a single ball, we note the number of that ball, and again that the ball has been goes to the bowel only. That means the probability of collecting that ball from that bowel will be remain same after each and every withdrawal. After each and every withdrawal, the population will be same. So this is called simple random sampling with replacement. That means that ball will comes more than one times. And without replacement means, suppose initially there has been 6 ball, after the first ball has been collected, there has been the remaining 5 balls. So that means the probability of the remaining 5 balls of outcome is 1/5. This is called without replacement, simple random sampling without replacement. So what is the difference? The main difference is that in simple random sampling without replacement, after its replacement, the probability of each ball is remain same, and without replacement, what will happen? After each withdrawn, the probability of coming each ball is decreasing. Clear? Now the next part, this is a unique type of sampling you can do when your data is homogeneous, as well as when your population size is small. That is called double random sampling. What is double random sampling? Initially, we can suppose uh, take that 1,000 households, we go to Tripura and collect some data regarding tribal people of 10% data. That means 1,000 uh, households we have already studied in simple random technique. Now we will see that after analyzing that, there has been some little bit of biasness has been coming. After that we will see, because how we will see that, we will see that there has been lots of house, their family income is quite large, and there has been few house their family income is quite low. So this scenario cannot match with the population scenario. So what we will do again from that point of view, that we can do again a simple random sampling from that 100 household. So we will do 2 times of simple random sampling at the type of investment. Initially, we gather directly from the field and we have 100 household data. And after that, when we take another, when we take another type of sampling there, so what we will do, we will take 50% of data from 100 household. That means 50 household we will study. So we will take data 2 times with the help of simple random sampling. This is called double random sampling. This is also more useful when your population is homogeneous as well as your population is small. And another most important thing is that after collecting data, lots of errors, lots of biasness will come. So we can check these biasness with the help of double random sampling technique. Now the third one is systematic random sampling. What is systematic random sampling? Systematic random sampling is a unique version
Sir,
of,
sir,
yes,
I have question.
yes,
Uh,
yes,
Under double random sampling, when we take when we take random sampling twice, in that
yes.
case, is it so that sample size remains same?
No, no, no. How sample size remains same? Suppose initially in first step you will take 100 household, okay?
Okay.
Then what, after analyzing it, you will check that there has been some little bit of error, or there has been some gap between your sampling result and population result.
And
So
population
at that,
parameters, yes, sir.
yes, so at that point of time, what you will do, you will
Sample
never
size will
go to,
increase.
you
Yes, sir.
will know, you will never go to Tripura and again collect some data. This is not possible at that point of time. So you can do again random sampling from those 100 households.
Okay.
That means your sample size is reducing. Suppose you take 50% household from your sample. That means total now you will study 50 households, 50 tribal households.
Okay, sir.
Okay.
Acha.
Okay. Now, the third point is systematic random sampling. This is another most important probabilistic sampling. Actually, during the time of inquiry in field, you will face a little bit of difference, little bit of disturbance, that which house I will go to collect data, since you are collecting data in randomly. So this problem can be solved through systematic random sampling. In systematic random sampling, what you will do, suppose there has been 100 households, 100 house in a village. So you know that this house is number 1, this house is number 2, this house is number 3, like that this house is number 100. You will give a imaginary number of these houses. So after that, you will decide that, suppose we are taking a huge amount of data from that village. So you will collect third house after interval. That means you will collect data from third number of house, after that sixth number of house, after that ninth number of house, after that 12th number of house, and like that. So this is quite easier for us because when we are going to collect data from the field of inquiry, we have to face that problem that may this house is suitable for us, that may they can give data to us, may they have that knowledge that I want to know. These problems can be solved through this systematic random sampling, because you will determine that yes, I have to go that fifth number of house, after that I have to go that 10th number of house. So these questions are not valid that point of time, though, that they are giving information or not, that they are presentable to me. These things are not become important for that type point of time when you are using systematic random sampling. That means there has been a interval between the samples, uh, which samples you want to collect. And This is the most, actually this is the most useful technique, because actually I am studying tribal livelihood for last 14 years. So I have seen lots and lots of incident there. So everyone, actually they are quite backward. Actually they want to give information a lot, that so that they can some benefit from different institutes and like that. uh, when we go there in remote villages, every household, suppose there has been a village where 100 households are living, they are trying to give every households come us to give data. So this is also become a huge problem for us to collect data at that point of time. So this problem can be solved through stratified random sampling. You also asked your that households, that those houses number 5, number 10, number 15 and number 20 and like that, you will only come here and give your data. And for that reason you can smoothly collect your data, and you can fulfill your objectives as well in a relatively quite less time also. So systematic random sampling is quite uh, scientific and quite less time consuming also, and you can easily collect your data according to your objective through systematic random sampling. After that, here I have give a picture that there has been 12 members living in a village, and we will collect number 2, that every third we will collect that number 2, number 5th, number 8th and number 11th household for collecting our data. So when you want to collect data easily, suppose you have a small amount of population and your data is homogeneous, suppose tribal family, that means you can easily collect data through systematic random sampling, because in random simple random sampling there has been lots of error will occur for collecting, for selecting that particular household. So that can be easily removed through systematic random sampling. Clear? Now, the fourth most important part of sampling technique, that is called stratified random sampling. Actually, initially we have taught three types of sample, that is simple random sample, double simple random sampling, and finally that systematic sampling. These three types of sampling can be done when your data are homogeneous. This is the most important part. When your data are homogeneous and when population size is small, you can collect data through simple random sample, double random sampling, and systematic sampling. Now, in real world, what will happen? Your data, your field of inquiry is not homogeneous at all. They must be heterogeneous. So how will you collect data? You can collect data through stratified random sampling. Now, what is stratified random sampling? Stratified random sampling means you want to, suppose you want to study a population and there has been lots of homogeneous data are there. Suppose you are studying a particular village. Suppose you are studying a particular village. So in that village, there has been some general households, there has been some tribal households, there has been some SC's household, and there has been some OBC's, other backward class also households. So you initially what you will do, you just break the total village into four types, four strata. You can break the total village into four strata. Strata 1 for general people, strata 2 for tribal people, strata 3 for that scheduled caste people, and strata 4 for other backward class people. And from each strata you will collect data randomly, because when you select each strata, that means each strata become homogeneous. Total village is heterogeneous, but when you distribute your village into different strata according to your homogeneity, that means now all these four strata are become homogeneous. After that, you can use either systematic sampling or simple random sampling for collecting data. That means stratified random sampling can be used when your data are homogeneous, sorry, when your data are heterogeneous. That means there has been a problem, there has been lots and lots of different means, lots and lots of different variability in data. That means you have to more uh, cautious for collecting your data. So how you collect your data? First, the whole village, you can distribute your whole village into different strata. After that, each strata become homogeneous. Now you can collect data through simple random sampling or systematic sampling according to your willingness. Clear? Is it clear, or may I proceed?
No, sir, it's clear, sir.
Okay, thank you. I have given a diagram for you. Suppose here 12 households are living in a village. That means that 12 households, among 12 households, number 1, number 10, and number 12 from one community. Number 2, number 4, and number 6 from another community. Number 7, number 8, number 11 from another, and number 3, number 5, number 9 from another. So when we uh, take that picture of population, what we will see that all are from different communities. There has been lots of communities living in a village. That means they are the data is heterogeneous. For our, what we will do, we just distribute the data, make a stratum or make a layer, make different layer of homogeneity for collecting our data. So what we will do, we make 4 different types, 4 different groups, 4 different strata for our collection. So after making different strata, we will take data from each stratum. Let's see, number 10 has been collected from first part, number 2 from second part, number 8 from third part, and number 5 from last part. So we collect all types of data through stratified random sampling in spite of population is heterogeneous. Okay. Now proceed to next sampling technique, that is cluster sampling. Cluster sampling is another type of sampling. After cluster sampling, there has been lots of question you can ask, because when I am a student, after learning sampling, I have a thought that that stratified sampling and cluster sampling are same, but they are quite different. Actually, what is cluster sampling? When your data is, similarly, when your data is heterogeneous, you have to distribute your data into different cluster like strata also. But the difference is that in stratified random sampling, what you will do, you just take data from each different strata. But in cluster sampling, what we will do, we will select total cluster at a time. Suppose I have given a yes, I have given a diagram here. Suppose our total village has been distributed in 6 strata, different clusters. In different clusters, 1, 2, 3, 4, 5, 6, 1, 2, 3 in one group, 4, 5, 6 in another group, like that, 13, 14, 15 in another group also. Now, in cluster sampling, what we will do, we will select total cluster at a time. Suppose in this diagram, we will select 2 cluster. Number 1 is first cluster 1, 2, 3, and final that second one is 10, 11, 12. This cluster has been collected randomly. So the basic difference between stratified random sampling and cluster sampling is that in both the cases, we will divide our total population in either different strata or either in different clusters, same thing. But in stratified sampling, we will collect sample from each and every stratum. But in cluster sampling, we do not collect data from each and every cluster. We only collect data of total cluster. Is it clear? You can ask a question regarding cluster and stratified sampling is if there has been some. If there has been no queries, I can proceed. Okay. Am I audible?
Yes, sir. Clear, sir.
Okay, okay. Thank you. Now the final stage. This is the mostly useful sampling technique for your uh, fulfilling objective. This is the most useful technique for collecting data. This technique is called multi-stage random sampling. So what is multi-stage? What is multi-stage random sampling? Multi-stage random sampling means we have to divide our whole population into different zones. After that, we will collect data from population. I am giving an example so that you can easily clear. Suppose we are collecting data on tribal livelihood. So through multi-stage random sampling. So what we will do? We have to divide our total population in different stages. How we will divide? Since we are studying tribal population, we have census data of government. So from that census data, in first stage, we can easily identify those states where tribal population is predominant. You can easily do through our census data in first. This is our stage one. In stage one, what we will do? Suppose we are selecting four states where we are getting tribal predominance. This is our first stage. Now in second stage, we have four states. Now in each state, there has been lots and lots of districts. Now in second stage, we will select different district where tribal population is large. This is our stage 2. So in stage 1, what we will do? We will just select the states from where we can get tribal dominance. Now in stage 2, what we will take? We will select those districts where tribal population is large. This is our stage 2. Now in stage 3, there has been lots and lots of blocks are present in different districts. Now in stage 3, we will select different blocks where there has been tribal predominance. So in stage 1, we will select state. In stage 2, we will select different district of tribal dominance. And in stage 3, we will select different blocks where tribal population are large. And in stage 4, we will select those villages where tribal population is huge. These are the four different stages of multi-stage random sampling. That means when in we after doing our literature, we have a knowledge that we have found some gap, that there has been lots of study. We heard about city people, we heard about the common people, those who are living in different cities, municipalities, towns, but in different villages also. But there has been lots of work that will be done for tribes, because since they are living in mainly forestry, their collection of data is quite disturbing for us. So for that reason, we have to select multi-stage random sampling, because the target sample, to find that target sample, we can only use multi-stage random sampling, because without multiple random sampling, we cannot go to that tribal household which I want to get data from him or her. That means there has been some stages, different stages. First stage is for state, second stage is for districts, third stage is for different blocks, and fourth stage is for different villages. And finally, after selecting those villages, we can collect data through simple random sampling for our study. So this is the most useful, most systematic, most scientific way to collecting data. Now I have given a flowchart diagram like that. The same thing that I have discussed here. The total that map ABC, this is suppose this is a country. Uh, there has been in the first stage we have select the states, and in the second stage we have select the districts, and in the third stage we have select the villages, and here also I have given another, that is block. In the fourth stage we have select villages. In the fifth stage we have select households, and after that we have collect data randomly, that we have select three households, A, B, and C. And let's see that A, B, and C has come from different states and from different district, different blocks, and different villages. So this is the most scientific probability sampling technique when you are collecting your data from directly field of inquiry. So for collecting sample, initially we have probability sampling technique. In probability sampling technique, mainly we are using four. I have taught you five, but mainly we are using four types of data. That is simple random sample, systematic sampling, stratified sampling, and cluster sampling. In simple random sampling, we can do anything according to our willingness, which is easily accessible for us. In systematic sampling, we will have some criteria that we can select that number, that 10th household, 20th household, 30th household, we can take those data. This is according to our research criteria for systematic sampling. Stratified sampling, we have to take data from each strata. Cluster sampling, we can collect totally data of different clusters. And finally, multi-stage sampling, we can target our population through sample that we want to study. So these are the 5-6 different type of techniques of sampling, particularly probability sampling, that we can use directly from the field of inquiry. Okay, you can ask questions regarding probability sampling if you have. Okay, now next, that initially that table that I have given to you, that is this different type of sampling method. So the left hand side, all the classifications has been discussed, and it has been quite clear for you also. Now the second part, that right hand side part, that is non probability sampling. Now what is non probability sampling? Non probability sampling means that there has been no equal opportunity or probability for selecting the members of the sample. That means we are not taking any probability or no equal opportunity for the samples to be selected. Probability sampling means all the samples have equal probability to be selected, and non-probability sampling means all the outcomes, all the sample do not have equal opportunity or probability for selection. So in non-probability sampling also there has been some different techniques that we are discussing. First one is convenience sampling. Actually, convenience sampling is quite popular in uh, those cities and in those areas where there has been some malls, or there has been some delivery system, online delivery system, that Amazon, Flipkart, boys and girls are giving those products to our home, and like that. They are actually doing that convenience sampling. What they do after delivering a product, they will ask you, sir, I have sent you a message, and click on that message and give some feedback regarding us. So what is that feedback? That feedback is the qualitative data. That when nowadays what we will do, we also if we want to buy something from online also, or suppose we want to travel a place and select a hotel, and we also check that what are the reviews are given, what are the stars are giving to that property. So these stars are nothing but the quality of that hotel. That means these are the qualitative data. So convenience sampling means when you are collecting data according to your convenience. This is called convenience sampling. Suppose two young boy, they are studying in their college, they are standing in front of a shopping mall. When you are visiting in that shopping mall, they will come in front of you and they will ask that what are the service you are getting from here. There has been some questions regarding that, and we are easily giving those answer, and they are collecting the data through their according to their convenience. They are not collecting their data according to probability sampling. They are collecting to data according to non-probability sampling, because the outcome are not equal probability, not have equal probability. They only collecting data according to their convenience. So when you collect your data according to your convenience, this is called convenience sampling. And there has been some nickname also of convenience sampling. These are called accidental sampling or incidental sampling. Actually, convenience sampling is those type of sampling where you have much less amount of time for your analysis, for your study. So what you have to do, you cannot maintain your probability, you cannot get that amount of time so that you can collect data through stratified random sampling or through multi-stage random sampling. So you have to collect data quickly, and you have not have that amount of money you can spend from collecting data. So you have collected data according to your convenience. What type of data you have some objective, and you go to that place, and that households or that members what you are getting, you are collecting that data. So these are called convenience sampling. And another most important thing of convenience sampling is that those who come first, those are the samples. Those who come later, they are not the part of the sample. This is the one of the drawbacks of convenience sampling. Suppose you want to study that what are the different age groups coming in a shopping mall for a particular event. So suppose you have some estimated data that there has been different type of age groups are coming in that shopping mall, but initially you are when you are collecting data through according to your convenience, you said that college going young peoples are coming initially, and you are collecting those samples. That means first who are coming to you, you are taking data from them, but after that those who are coming are not, you are not taking data from them also. So this is, so this type of sampling, through this type of sampling we cannot get that reflection of population properly uh, through convenience sampling. Okay. Now another type of non-probability sampling is judgmental sampling. This sampling is also popular as purposive sampling. Now what is purposive sampling? Purposive sampling means the sampling which you are doing according to your own judgment. Totally, the sampling process is depend on researcher's point of view. This is if suppose you are want to survey a, tribal village, that how many tribes are living there and what are their monthly income. Now since so what you will do, you are finding a friend of your classroom whose hometown is from a village, and you asked him that do you have some tribal family living in your village. And he said that yes, I have some family, tribal family living in my village. Now you will, what you will do, you will tell him that let's go for a travel, and I will also visit to your home and take some data from your village of those tribal family. That means that tribal family has been selected according to your judgment, to your purpose, because to your purpose means that village is easily accessible to you and you can easily collect data from that village. There has been no probability regarding the selection, no randomness, no stratified, no systematic, nothing. You have only collect data according to your purpose. This is called purposive sampling. Now the third part, it is another most important part, most important technique of sampling, that is called quota sampling. Quota sampling is quite similar to our cluster sampling. In quota sampling, what we will do, similarly in cluster sampling, what we have done, we have divided our whole population in 3, 4, 5, 6 different clusters, and we have select 1, 2 cluster as a whole randomly. In quota sampling, the concept is totally same. In quota sampling, we will divide our total population into different quota. That means in different cluster also. These are the synonymous word. In different quota. After that, we will select. Suppose we are we can divide our total population in 6 group. Now, after dividing those 6 group, we will collect 2 quota at a time, two groups totally as a time at that point of time. These are called quota sampling. Now the difference is that in what is the difference between cluster sampling and quota sampling? In cluster sampling, all the outcomes may come under same probability. That means they have been probability distributed. That means the villagers, that household, the selection of that household will be same. But here in quota sampling, the total sampling technique is non-probability. We can use quota sampling according to our judgment. There has been no probability, no possible outcome of selection. The total technique is our own judgment. That means our own purpose. For our own purpose, we can distribute that villages in different groups, and after that we are selecting 1 or 2 groups according to my willingness or according to our purpose. After collecting the data, the whole technique is called quota sampling. That means the basic difference between cluster sampling and quota sampling is that there has been a probability distribution, that the outcome of selecting each variable is same. For cluster sampling, for quota sampling, the whole output will be selected according to researchers' willingness, according to the purpose of researcher. Final, snowball sampling. I will giving a funny example to explain the snowball sampling. What is snowball sampling? We have seen lots and lots of videos in social media nowadays. Suppose a little bit of snowball, if thrown in a valley of snow, the snowball is become big and big when there goes down and down and down. That video is quite popular in social media. This concept is called snowball sampling. Actually, a snowball sampling means, suppose a investigator, suppose a police want, there has been a large gang of a gang. They are doing some theft in a city. Now police didn't get access of that gang. Suppose a one guy has been supposedly arrested by a police. In between that gang, a one guy has been arrested. Now what police will do? They inquired him that how many people are there, and suppose that the guy has still the name of 2 other people in that gang. Now police will again arrest those 2 people and started inquiring that who are the other members are there in your gang. Now that 2 guy again tell some names. That people has been arrested by the police, and after that, that new guys, those are arrested, they are again inquired, and in this process total gang will be arrested. That means chain. If we get data in chain ways, that is called snowball sampling. This is the unique way of sampling technique. Actually, in different chain management system, this technique has been used. We have lots of knowledge regarding chain business. In chain business, this snowball sampling is quite popular, and snowball sampling is quite useful also. So these are the four different types of sampling technique in non-probability part. Now, in non-probability sampling, if we want to recap the whole thing in non-probability sampling technique, we will see there has been mainly four different techniques of non-probability sampling. First one is convenience sampling. Convenience sampling means the sampling the which are easily accessible for researcher. Purposive sampling means the sampling which are done only for the researcher's willingness, researcher's purpose to meet research criteria. Another one is quota sampling. The total population has been distributed according to the willingness of researcher into different quotas, and after that, each sample has been collected from different quota. That is called quota sampling. And finally, snowball sampling means the sampling has been started from 1 or 2%, and after that, from those 2% we can get data from another 4%, and from that 4% we can get data from another 8%, and through this process we can collect lots and lots of sample data for our study. So these are the four different types of non-probability sampling techniques. Okay, is it okay?
Yes, sir. You please carry on, sir. It's fine.
Okay, okay, okay. Now, if you are collecting data from the field of inquiry, you will. There has been some questions that are coming in your mind that what will be the appropriate size of sample that we have to collect from the field of inquiry, since we are living in an economy where the population is increasing day by day by day. If we want to collect data for trials, if we want to collect data from schools, if we want to collect data from different municipalities, the population size is increasing day by day. So since we have learned that lots of technique of different sampling, but the question is what will be the appropriate sample size, that what amount of sample we will collect from the field of inquiry for our study. Actually, the answer is that it purely depend according to your requirement. But the rule is that you have to collect 10% data, 10% sample from your total population. Suppose you have a village where there has been 500 household living. So you have to collect at least 10% data, at least 10% data. That means you have to study 50 household, at least 50 household. If you can take more than 50, that suppose you are taking 15% data, suppose you are taking 20% data, that will be more helpful. That analysis will be quite better than if you take 10% of total household. But the rule is that for analyzing any data from field of inquiry, you have to collect at least 10% of your data. Another technique is also popular. Suppose you are collecting data from a field where data are homogeneous. So in case of homogeneity, we know that population size is quite small. Now what you will do at that point of, suppose you are going to a village where the total number, suppose the village is in the top of a hill, so the number of household is quite less. Suppose the number of house, total number of population is 15, so 10% means 1.5, that is quite less. So what you will do at that point of time? So there has been another rule is that for this reason, suppose you are inquiring those people who are living, whose data are homogeneous, then you can select a number, particularly a number, that those number of samples can be collected from each village. Suppose you have to collect data from 10 villages, and in each village there has been house number of households is more than 15 or 20, then each village have more than 20 households, that so that at that point of time you cannot take data that on 10%, 20%. Better you will select absolute number, an absolute number. Suppose you will collect 10, you will data 10 households from each villages. This is also a good concept. So there has been two concepts. What will be the sample size? Number one is the percentage form if your sample size is large, and if your population size is large, and if your population size is small, you can better concentrate on absolute number. Obviously that absolute number will be more than 20%, 30%, since your population size is large. These are the two techniques that normally researcher will use for collecting sample. One is that percentage form, uh, greater than 10%. Try to collect data more than 10% for reducing the sample errors. And another one is if your population size is quite small and population is homogeneous, then try to collect data particular on a number basis. Suppose you are taking data 10 households for each villages that you want to study. So these are the main answer that what will be the appropriate sample size. uh, I think it is quite clear for you that what will be the best number, best appropriate sample size. Now another main thing is that since we have studied 10 different type of sample techniques that through which we can collect data from the directly from the field of inquiry. There has been lots and lots of questions coming that what will be the best sample technique that we can use for our research. From my point of view, the best sample technique will be multi-stage random sampling technique, because through this technique you can collect data directly you want to fulfill your objective. Suppose I am collecting data of tribal people, and since I am from West Bengal, there has been lots of district where there has been predominance in our hilly regions. There has been predominance of tribal people, but if we want to collect data from that multi-stage random sampling, West Bengal is not coming in that multi-stage, because there has been lots of other states where tribal dominance is tribal population is predominant. So this can only be selected through multi-stage random sampling according to your objective. In multi-stage random sampling, total data is going through different stages according to your requirement. Suppose I am giving another example to clarify this. Suppose you want to study the women empowerments. You want to study some data of women empowerment. So what you have to do, in first stage you will find that those states where there has been the employability, the accessibility, and the opportunity of women is larger. In first stage you have select in first data one, sorry, in stage one you have select that thing. In the next stage you will select those district where women are getting more jobs and they are more employed, they are more family headed, like that, they are more wealthy. Select those state in the next stage. In the next stage, after that you will select district like that, then select block like that, then select village or town. Suppose here we will take town or cities like that. And after that, from those cities, you can take randomly to those women's or to those women headed household where women have taken charge of whole thing. So through this technique, you can easily get your data appropriately according to your research work. So this is the multi-stage random sampling is more systematic and more scientific process, and through multi-stage random sampling, sampling error are also quite less than other sampling technique you can use. So according to me, multi-stage random sampling is a very good systematic sampling, and you can definitely use if you want to collect data directly from the field of inquiry. Thank you. So for last more than an hour, I have discussing different type of sampling techniques, and what will be the different which will be the different best technique, and what will be the number of sample that we can use. These are the most important things that we have completed. Now, suppose we are completing our sampling and we have collect data from the field of inquiry. Now, what we will do later? Now, we have to select our variables. We are discussing about women empowerment. We are discussing about tribal livelihood. Now, we have to select. We have lots and lots of data. We have to select which data would be our dependent variable and which data are our independent variable. Dependent variable means the data which are explained variable, and independent variable means presiding variable. Independent variables are those variables which can be explained for dependent variable. You have learned about in your previous session that about independent variable and dependent variable, I think so. And actually independent variable and dependent variable have nothing to do. Independent variables have lots of things. That suppose we are want to studying the income, family income of a tribal group, suppose. So what will be the in this is our dependent variable income, family income, monthly income. Now what will be the independent variables in those cases? Independent variables, maybe their household size, maybe their education level, maybe their occupation, maybe their type of house, land holding, uh, the head of the household, male or female, how much cattle they have, and lots of variables are can become independent variables, and they have some influence on dependent variable. So after collecting data, we have to select our main dependent variable, and after that we have to select different independent variables that have an influence on dependent variable. Now the next part. So we have selected all dependent variables and independent variables, but during our analysis, we have see after doing regression that the result is not coming properly. So to avoid this, we have to check initially after deciding that this is my dependent variable and these are my lots and lots of independent variable. We will check the correlation criteria. What is correlation criteria? Correlation criteria is we will check the relationship of particular independent variable with dependent variable. Relationship between a particular independent variable and dependent variable will check through correlation coefficient. And suppose we see, this is quite natural, that if you are more educated, your occupation level will be more. So there has been also a relationship between two independent variable also. This is called multicollinearity. Multicollinearity means if there has been a relationship between two independent variables, the result of your model is not become appropriate. For reducing multicollinearity or for removing multicollinearity, we have to check variance inflation factor, that is called VIF. If VIF will be less than 5, if the value of VIF is less than 5, that means your model have multicollinearity which is quite minimal. That means you can go through your model. If the value of VIF is ranging between 5 to 10, that means multicollinearity is present. That means you have to check your data again. And finally, if the value of VIF is greater than 10, that means your model has been a lots and lots of biasness. You have to check your data again rigorously. So before regression, after collecting data, initially you have to decide which is our dependent variable, which are our independent variables. After selecting this, we have to check correlation criteria and the VIF factor. And after that, we can do regression analysis. I will say nothing about regression analysis because you learned a lot in your previous session about regression analysis. Regression analysis is nothing but the relationship between the dependent variable and the lots and lots of independent variable, and through which we can get some knowledge that for these factors the livelihood of tribals has been changed, or for these factors the income are influenced for tribal livelihoods. This is the concept of regression. But the main problem for analyzing is, 1 minute. Huh. Now, uh, these problem, since we have collected data from the field of inquiry, and we have suppose 20 variables, 20 independent variables, and we have found that more than 15 variables have we have checked our correlation coefficient, and there has been 15 variables that have an influence on our dependent variable. Now what we will do if we do that OLS or simple regression or multiple regression? We will find a model where the value is quite less. That means the model is not well fitted on that case. So what we will do? We will do stepwise regression. Now, what is stepwise regression? Stepwise regression is too much useful for our researcher, because in stepwise regression you can easily select those variables whose have those, particularly those independent variables whose have better relationship with dependent variable. Clear? Through stepwise regression we can select those variables which have more influence on dependent variables. Now what the problem is that in regression, in ordinary regression, in multiple regression, there has been the forward regression. Forward regression means we will sorry, backward regression, we will take all variables at the point of time and they will give the data. But those variables who are not important for that model, we cannot eliminate that model, we cannot eliminate that variables, or further we cannot take any other variables, we cannot inject any other variables in that model. That problem can be solved here. Suppose you have 15 variables, 15 independent variables. Initially what you have to do, first there has been you have to do some initial step. After that you can do that regression. First you have to make the correlation matrix. Correlation matrix means you have to check the correlation of independent and dependent variables. This is the first concept. You have to check the relationship between dependent and independent variables. This is the first most important thing. Now we have found that lots of variables have significant correlation values. Those we have to select that independent variables which have more highest correlated variable, which have highest correlated variable. You have to find that variable, you have to find that variable which have highest correlated factor. So first variable has been selected. Now check the regression with the help of linear regression. Check that regression, do that regression with one independent variable. Now after doing regression, check the test of significant, that the model is significant or not. If the model is significant, then you can take further next variable which is more correlated. Now go through this process, and now suppose if that variable is not significant, when you test that test of significance, if that variable is not, if that first variable is not significant, remove that variable. This process is going on and on for that 15 variables. Maybe it is clear. I will explain it again. What we will do, initially we will take suppose 12 variables. Initially we will take 12 variables. This can be done with the help of SPSS software. In SPSS, what we will do, go to analyze, then from analyze go to regression, then select linear. From linear, select the variables, what will be your dependent variable and what will be your independent variable. Then go to statistics. Now after go to statistics, select stepwise and enter or OK. Now after doing this, you will get a outcome, SPSS outcome like this. First, this is quite common in if we analyze your data in Excel or Stata or SPSS. Any regression, for doing any regression, initially you will get data of descriptive statistics, while we get the mean, standard deviation, and those all things. Now after that, sorry, mean deviation and standard deviation and all things. After that, the model gives you this type of result. Here you will get three columns. First one is model variable entered, second one is variable removed, and third one is the method. That means if the probability of f is less than equals to 0.5, the variables will be selected, and if the probability of f is more equals to 10.1, the variable will be removed. Through this technique, the first we will select variable 11. Second, the model will select variable 10. Third, the model will select variable 8. Like that, only 3 models has been selected here. In model summary, we will see when the variable 1 is selected, the value of adjusted R square is 0.39. That means only 39%, 39.3% of the model has been explained. In the second part, when variable 11 and variable 10 are taken, the value of adjusted R square has been increased to 44. That means the model has been explained to 44.4%. When the model gives the third variable, that means variable 8, the 3 variables totally will explain 46.2% of the model. This is the beautification of stepwise regression model. On the other hand, this is the selection part. Now in another part, the excluded variables, you can also check from here that other variables, initially in model 1 there has been lots and lots of variables, where you can check the value of beta. In the next column, the value of beta of variable 10 is minus 0.226. So this is the more beta, value of beta is more. That means we can remove that data, we can exclude that data in the second model. Check that second model, there has been no variable 10. There has been no variable 10. And finally, in model 3, Similarly, that the value of variable 8 is quite larger. So in model 3, we can omit. Actually, we are not omitting. The software is omitting. So stepwise regression will give you, if you have lots and lots of data, independent variable in you have collected. So which variables are mostly suitable, that can be easily done through stepwise regression model. I can explain these stepwise regression model and beta regression model later with the help of software if we get some time later. That will be more helpful to you. But there has been some limitations of stepwise regression also. The limitation is normally stepwise regression in we will use for demographic data, since we have discussed about that income of tribal family or that livelihood of tribal family. So normally stepwise regression has been used for demographic data analysis. And another most important thing for stepwise regression is that if the two independent variables has highly correlated, suppose suppose education and occupation. Normally education and occupation are highly correlated. So for stepwise regression, we can only take either occupation or education to for getting better results of stepwise regression. And another point is that collinearity is the major issue. So collinearity can be removed through that we have discussed earlier through VIF. And another point is that some variables called may be removed from the model. Those are dummy variables. Suppose we are taking three states. So for taking states, we have to use two dummy variables. For stepwise regression, we are trying to remove those models for our better estimating our model. But if your dummy variable is important for your analysis, you can take stepwise, you can take those data for your stepwise regression. So the most important thing for our research is why we use stepwise regression. We can use stepwise regression because since we are collecting data from field of inquiry, that means we have lots of variables which are influencing our dependent variable, which have some influence on our dependent variable. Then how we can estimate which variables have better influence on our dependent variable, that can be easily addressed through stepwise regression. This is the most important thing. And we can also eliminating those variables which do not have any significant relation with dependent variable. It is clear, maybe.
Yes, sir.
Okay.
Yes, sir.
And finally, our final part, that is beta regression. Beta regression, actually, this is has been formulated by Ferrari and Neto in 2004. This is a special type of regression. We have heard about human development index, gender development index, and all the economic, all the statistical that parameters, that indices that we are learned, we are calculating, all comes into, suppose our that human development index, the value of human development index is ranging between 0 to 1. That means those who have tending towards 0, their human development is quite less, and those have tending towards 1, those who have 0.99, like that, they have high development, high human development. That means human development index have a data ranging between 0 and 1. Human development index have a data ranging between 0 and 1. If we have a data that have a distribution, that have a value between 0 and 1, we can use beta regression. Suppose we are calculating Gini coefficient. Anything related to rates, anything related to proportion, anything related to inequality ranging between 0 and 1. This, if your value of dependent variable is ranging between 0 and 1, we can use beta regression, because beta regression can gives you bet if your value of dependent variable is ranging between 0 and 1, easily you can easily do your OLS. Simple or multiple regression, you can easily use simple or multiple regression technique. But if you use beta regression, then the model will be more explained, since the value of dependent variable is ranging between 0 and 1. Suppose you can take, you in online, you can get, easily access some data of HDI of India or other states. You can check by your own, take some data of human development index as dependent variable, and take some variables that their life expectancy, their standard of living, and their education level. Take three data and check on your own, that you will see that the model will be better explained through beta regression. Beta regression actually is a technique. We can use beta regression when there has been um, the value of dependent variable is in proportion or in rate. So you can use beta regression. How you will do beta regression? Initially in stepwise regression, I have explained in SPSS. Now I am explained in Stata. You can do both beta regression and stepwise regression in Stata and SPSS also. No issue regarding that. Now, in Stata, you can give command also, as well as you can get drop-down menu also. If you want to give command, you can just write beta regression, beta reg, and you give your dependent variable and give other independent variable. And if you want to do it by drop-down menu, go to statistics, then fractional outcome, and then beta regression. Now, there has been also some limitations of beta regression also. What are the limitations? The main limitations is, in other regression technique, you can take direct data from the field of inquiry for dependent variable. But for beta regression, you have to calculate the indices or coefficient of your dependent variable initially. Suppose you are calculating human development index of Lucknow. Then what you have to do? You have to collect that life expectancy, you have to collect that school dropout ratio, adult literacy rate, and you have to collect that per capita income. Then after that, you have to normalize all those values. Then after that, you have to average all those things with weight. Then you get the human development index of each family who are living in Lucknow. That means for beta regression, the main problem is that you cannot get direct, you cannot give direct data to your regression. You have to initially collect those data, you have to normalize those data, and you have to calculate that coefficient. After that, you can give your dependent variable. This is the most demerit of beta regression. And another point is that in assumption, we have learned that in beta regression, the regression lines is in linear relationship. But this is not the case. Actually, when we are ranging the data between 0 and 1, so if we plot that data on a scatter diagram, we will see the data will not give a linear relationship. You can check. And finally, the main limitation of other regression model, the same is also applicable for beta regression also, that we cannot eliminate any independent variable from this data, as well as we cannot what we say, we cannot inject or we cannot take any new data. for our modeling in beta regression. So these are the two unique and interesting techniques of regression. One is stepwise regression for young researchers, and for us also. Stepwise regression is quite interesting. I have used stepwise regression in lots and lots of my works, and which is also too much useful for us, because we can easily eliminate, or we can easily determine those factors which can be easily explain our dependent variable. And finally, beta regression, again beta regression is also useful, though it has some limitations, but beta regression is mainly useful if you can calculate your dependent variable. So beta regression can more give more explanation than OLS. So these are the two main factors, these are the two main regressions, that two special regression that we have studied today. In spite of these, there has been lots and lots of other regression we can easily access. You can also do anything, that you can merge this stepwise regression, and after doing stepwise regression you can check it through also beta regression for better result and better analysis. So thanking you. May I can explain all the things that I have discussed here.
Thank you so much, sir. And I think Annapurna madam has raised her hand.
Okay, I haven't seen it. Sorry.
Dr. Annapurna, do you like to ask some query? Annapurna madam, please, you can unmute yourself. Perhaps she cannot mute herself, no issues. Yes, any other participant, any query that you would like to ask Dr. Sourav? Well, sir, from my side, I would say that yes, stepwise regression and beta regression have been a really new thing for me, because we have been using only simple regression analysis, and these two have really opened new vistas. How to actually as you told, forward and backward can regression, it helps in doing that, and how to remove those which are not very much applicable, and we can actually determine the ones who are really responsible. So this stepwise regression, I hope in the coming future, it is going to be a part of my regression analysis to make a better analysis and to make a, I can say, a better reading and better interpretation of the connectivity of the interrelation of the independent and dependent variable. So, okay, Annapurna has written, sorry by mistake, hand has been risen. Explanation is very much clear and no doubts are here from her side.
Thank you.
So we really thank you, Dr. Sourav, on behalf of all the participants and on behalf of Department of Economics, for really enriching us with your, you can say, such a comprehensive lecture that you have, deliberation that you have actually presented here. And because each one of us, I think, as a beginner, we go in with the regression analysis. We do that. Correlation, regression are such tools that we all use in research. But then these two methods that you have introduced to us, beta regression and stepwise regression, I think many of us might be unacquainted with this, and now we are in a position to use it much better. So there have been, sir, lots and lots of feedback for you that, yes, it has been a very informative lecture from your side. Thank you so much, sir. And I really thank our faculty, Dr. Narendra Kumar, also for giving such a wonderful technical support. And all this data handling has been managed by him. Thank you, Dr. Narendra. And once again, any participant who would like to ask any question, they are free to ask. Yes, can we wait for you all? Nice presentation as given by one of the participants. So thank you so much once again.
Thank you.
And sir, you are most invited tomorrow also. We are having a last lecture. So we invite you again, and we hope to meet virtually again tomorrow. Thank you so much, and thank you so much all the participants.
Thank you.